Okay guys, today we're carrying on with parabolas. Today we're going to take a look at applications of parabolas, which is just like word problems. So our goal is to apply what we know about parabolas to models of real-life situations. There are many things in life that follow a quadratic or a parabolic model. A couple of examples: all projectiles move in a parabolic path in regards to space and time. So if you throw something in the air, and you relate the height as time goes by, that's going to give you a parabola. And there are some financial situations that also have a parabolic model applied to them. We're breaking the word problems up into two parts. The first part today is going to be questions where we're given the equation, and then the next lesson we'll take a look at how we have to create the equation sometimes. So in example 1 here, an angry bird is shot at a pig. Its height h. So h represents the height. Above the pig in meters after t seconds. So notice we're using h and t instead of y and x. So after t seconds can be modeled by that equation. So that equation represents the angry bird, the height of the angry bird as time goes by. And if you've ever seen Angry Birds or played Angry Birds before, you'll realize that, highlighter here, actually work. You can see the dotted white line here is a parabolic arch. Okay, it's a parabola shape, and the whole game is based on that pattern. So let me just get rid of this guy. So we're going to take a look at this example that involves Angry Birds. Okay. So we've got the equation. The first question says, what is the maximum height reached by the bird? So remember that when it's in vertex form, we certainly know what the vertex of this parabola is. So the vertex of this parabola is 229. If we drew a picture of this graph, so the angry bird is starting a little bit above the ground. We've got the pig over here. And the angry bird's on the slingshot, which is in the air. It's going up in the air, and it's coming down towards the pig. So that 229 is the point at the vertex for that parabola. So if we're talking about the maximum height that the angry bird reaches, that's going to be the 29 meters. Because in our graph here, we're measuring time on the bottom here, and that's 2 seconds, where the vertex is, and we're measuring height up the side, and the height where the vertex is 29 meters. So the maximum height is 29 meters. The other part of the flip side of this type of question is that we'll often see them ask, when did it reach its maximum height? So if they're asking when, they want us to find t. They want us to find time. So the time when the angry bird reached its maximum height was at 2 seconds. So in all these questions, we're either being asked for time or height, and we're usually given information for the other variable. So if we look at C here, how much higher, so we're talking about the height, So how much higher than the pig was the slingshot that launched the bird? So we're actually trying to find that distance there. So if we're trying to find the height there, do we know when the pig was launched from the slingshot, we know what the time was, because if it's still in the slingshot, then 0 time has passed. So we're going to find h by substituting 0 into the equation for t. So if I do that, it's going to look like this. Negative 4.9 t minus 0 squared plus 29. So I put 0, whoops. Let me just fix that. I'm a little ahead of myself there. So 0 has to go in for the t, so it's going to be 0 minus 2. There, that's better. And then we can solve this equation for h. And to solve it for h, I'm going to move the 29 over, we can just go ahead and calculate this. We do need to figure out what we get with the bracket and the exponent first. So negative 2 we end up with in the bracket, and if we square that we get 4. And if I do negative 4.9 times 4 and add 29, I get 9.4. So therefore, the slingshot is 9.4 meters higher than the pig. Okay, so that's our answer for that one. The next one here, how long? So now I'm trying to find what t is equal to before the bird kills the pig. So we're trying to find the time. Do we know the height of the bird when it kills the pig? Well, if the bird is killing the pig, then it's hitting the ground, so that means its height is 0. So now I'm going to substitute 0 in for h and solve for t. This one's going to be a little bit messier. So if I take the equation that I had at the start, I'll put 0 in for h. T minus 2 squared. So there's our equation with 0 substituted in for h. Now I need to get the t by itself. So I have a lot of things I have to move away from the t. I'm going to move this 29 to the other side first. So that's going to become negative 29 on the other side. Now I'm going to move this negative 4.9 to the other side. It's multiplying by the bracket, so I'm going to divide it on the other side. All right. And when I divide those guys, I get 5.9184. There's more decimals there, but I'm going to go that far. I don't want to stop after 1 or 2 decimals because I want it to be as accurate as possible. 4 decimals is decent there. Once I get here, though, I've got a little bit of a problem. I have to move this squared to the other side of the equal sign. And what happens when I move to the other side of the equal sign is I take the square root of 5.9184. And then on this side, I'm just going to be left with t minus 2. So here's the deal, though. When I take the square root of a number, I'm trying to find the number that multiplies by itself to give 9. That answer could actually be positive or negative 3. So when I get my answer here, when I'm taking the root of this number, it's actually 2 answers possible here, a plus and a minus. So let's see what happens when I do this then. So I'm going to get plus or minus 2.4 there, and I get t minus 2 on the other side. So if I move the negative 2 to the other side, I'm going to get 2 possible answers for t. If I do plus 2.4 plus the 2 that's coming over. That's going to give me 4.4. If I do negative 2.4 plus the positive 2 that's coming over, I'm going to get negative 0.4. Now when I evaluate those answers, this answer here, we say is not admissible. Because remember, we're trying to find a length of time. We can't have a negative time there. It's got to be positive. So therefore, we've got our answer here. Therefore, it takes 4.4 seconds for bird to hit pig. Okay, nice. Now we're going to flip over and do the question on the back. Now, the last one we had in vertex form, we have to get things in vertex form before we can do anything with maximum and minimum values. So in this example, a punter kicks a football. Its height, h in meters, and t in seconds. So again, same thing as last time. Time is x. Height is y. If I'm going to find the maximum height here, I'm going to use, I could complete the square here, definitely, but I'm going to use my little formula. So from the equation here, a is negative 4.9, b is 22.54, c is 1.1. So in my little formula, negative b over 2a, it's going to be negative 22.54 over 2 times negative 4.9. And I should correct myself here, because remember that x in this equation is not x, it's actually t. So I'm just going to fix that right now. So that needs to be t that we're finding here. So when we calculate this, we get t is 2.3. So we've got the t part of the vertex. Now we need to sub in t equals 2.3, and we'll be able to figure out what the height is equal to. So in the equation, h equals negative 4.9, and then 2.3 squared plus 22.54 times 2.3, and then plus 1.1 on the end. And in this case, I can just punch all that in, and you should come up with h is equal to 27.021. So right now we can say, therefore, the max height is 27.021 meters. Nice. And there's the flip side of the question. We've got the maximum height. Now they want to know, when did it reach the maximum height? So remember, that's the other part of the vertex. So it reached maximum height at 2.3 seconds. So we'd use both parts of the vertex values there. Here we want to know what was the height. So we're finding the height when the punter kicked it. So when the punter kicked it, the time was 0, because the ball hadn't started moving yet, so the time is 0. So I'm going to sub t equals 0 into our equation. Now, when we're finding the height of the ball, so if I do a picture of what this looks like here, and I do find it helpful, and I would encourage you to draw a little picture of what this looks like. So we've got the punter here, and the punter kicks the ball in the air, and the ball lands over here. We're trying to find out what the height of the ball was when the punter kicked it. So we're trying to find that value there. And that value is the y-intercept. It is when t equals 0. I guess it's the h-intercept here. And if I sub 0 back up into this equation, that value on the end ends up being the answer to that. So if I do h equals, so it's going to be negative 4.9, negative 4.9, 0 squared plus 22.54 times 0 plus 1.1, I'm just going to end up with the 1.1 that's on the end. So therefore, the ball was 1.1 meters high at the start. The last one here, how long was the ball in the air? So how long means we're finding a time. The ball was in the air. Well, so we're trying to find out this length of time here. And at the end of that time, at this point here, the height of the ball is 0. So we're going to sub in h equals 0 into the equation. So now the equation is going to look like this. And we're going to use the vertex form of this. So I should have done this up above, but if I write this in vertex form, remember the negative 4.9 goes at the start, whether it's in vertex form or not. And in the bracket, it's going to be x minus 2.3 squared, and then the maximum height was 27.021. So that's what the equation looks like. Now I'm going to sub 0 in for h. Remember, this is h over here where the y was. So I get here, and here's where I have to move everything away from the x. So the 27.021 changes to a negative and comes to the other side. Then I'm going to divide by negative 4.9. When I divide those, I get 5.5145. And here's where you need to remember what happens next. So for this part, I'm going to take the square root of this side and do plus minus for that answer. So when I take the square root of the right side, I'm just going to have x minus 2.3. When I take the square root of the left side, I'm going to get plus or minus 2.35. So my two possible answers for, man, I don't want to get rid of x and y here. Go figure, a math teacher in love with x and y. So we are talking about t here. If I do plus 2.35 and then add the 2.3 that comes over, I'm going to end up with 4.65. If I do negative 2.35 and then add the 2 that's coming over, I get negative 0.05. So like it's the same thing that happened before, this answer here is not admissible. Can't have a negative time, even though sometimes you'd like to turn back time. So our answer then is therefore the ball was in the air for 4.65 seconds. And that would be our final answer for that. Okay, so we're going to have a few days to work on the word problems. Hopefully you found that okay. If you've got questions, we can talk about them tomorrow in class. Thanks.